questions from yesterday's closures lab. It's question 4. Question 4 is asking, write a function called sorted names by last name. So the function takes in an array of tuples, right? Of type string, comma string. So here the first argument in that tuple is a string, the second is also a string, and returns an array of tuples sorted by last name, right? And if we look at our example assert here, we have Johann Bach, right? Sorted by last name. The expected output will be Johann Bach, which is the first, stays the same, but followed by D, E, J, M, M, R, right? So far, so good? So we went from the input, which was not sorted by last name. The output, the expected output, needs to be sorted by last name. Everybody with me? Everybody with me? Right? So I take input, output should be sorted by last name, right? In that case, we have Remsky as being the last in that particular array. Everybody with me with that part, right? So far, so good. So let's go ahead and write the function. So right where it says your function here, let's give ourselves some space, right? So your function here, our function starts with the func keyword, right? The function name, let's just go ahead and copy the function name. The function name is sorted names by last name. Yulia, how you doing? Good? Okay, cool. So sorted names by last name, that's our function name, right? Our function, the input, what's the input of our function, Matt? What's the input of our function? So it's an array of tuples, right? According to what Yulia is saying. So here we expect to take an array of tuples. Our function has an external name called in here, right? We could use an internal name called names. And it's an array of tuples, right? This is our array here. We have our open bracket, we have our closing bracket, and we have our tuple parents. In our tuple, we have two types. We have string followed by another string. What's the return type of our tuple, Anna? Of our function? What's the return type of our function? So an array of tuples, right? So we'll go ahead and use our arrow here. And it's an array of tuples, as Anna is saying. Cool? So as far as the function signature goes, we are pretty much done with the function signature. We have the name, sorted names by last name. We have an external parameter name, which is in here. We have an internal parameter name, which it's up to you what you want to call it. In our case, we called it names, which makes sense, it's appropriate. We have a names array. And we have our tuple, right, array here, returning a tuple array. So the input we get, it's unsorted by last name. Last name is not sorted. Our objective is to output a sorted array where it's sorted by last name. Everybody with me? Input, remember from yesterday's exercise, recognize what the input is. So the input of our function unsorted last name array of tuples. The output of our function is sorted by last name array of tuples. All right. So we have our input coming in. This is our input here. It's an array of tuples. Our output is also an array of tuples. So far, so good. So far, so good? Okay, great. So the next step, we come into our function to continue solving the problem. So we need to sort by last name. We know how to use sorted on an array, right? So here we have the names array, right? Names array dot sorted. So we start out by saying names array dot sorted, right? Get in the habit of not using the compiler to autocomplete your closure. That's where some of the problems could begin, right? We know our closure name is sorted. So far, so good. The function is called sorted, right? That's what we're after. We know we could use trailing closure syntax, right? We've seen that a couple times for the week, right? We could use trailing closure syntax. That's good. The next thing is we know sorted takes how many arguments? Brendan. If you were to read the error message, it might actually tell you. Right. So sorted takes 2 arguments, which makes sense, right? You're trying to sort basket A against basket B. You can sort just basket A by itself. So we know at this point our sorted closure takes 2 arguments. So far, so good? At this point, we could name the 2 arguments anything we want. I could say tuple 1 and tuple 2. I could say names 1, names 2. So like that, I could say names 1, comma, names 2. Don't forget the in keyword. So our closure expects 2 arguments. I gave it names 1, names 2, right? So far, so good. The next compiler error we get in here is our function expects it to return a value. Everybody with me? So at this point, you press enter. So we stated that we have 2 arguments. This is good. We stated that we have the in syntax here, which is required for our closure. Now let's go ahead and actually find out or sort the tuple. Names 1. What's names 1? Cassandra, what type is names 1? It's part of a tuple, right? So it's 1. If we option click on it, right? Option click. Or we'll get an error because currently we have too many errors happening. So names 1 is one of the tuples that we're looking at, right? It's one of the names that we're looking at. Names 1 is one of the names. Names 2 isn't in the name. So now we have the 2 tuples. We could compare them. What are we trying to compare? Last name, right? We're trying to compare last name, not first name. How do we get access in a tuple? If we have 2 values, how do we get access to the second value? Dot what? Dot syntax, right? But dot, if you have 2, what's the second element? Not $1. So dot 1, right? So dot 1 would get us access to the second element in that tuple. Everybody with me? If I'm trying to access the first element, what is the syntax for it? Dot 0. Everybody with me? So your tuple goes from 0, 1 as an array does. Dot 0, dot 1, not $0. $0 represents the closure argument. Cool? So that's the difference there. Now, I could go ahead and continue my program here. I could say return names 1 dot, what do we say, 0 or 1? Dot 0, 1? Dot 1, right? So dot 1 is less than here says alphabetical from A to Z. Everybody with me? Less than means alphabetical. Let's do, so less than here means ascending is the technical term, right? Or A to Z. If you wanted to go from Z to A, it's called descending, or Z to A. Everybody with me? Okay, so now we want to compare names 1 against names 2, dot 1 here. So what's names 1 and names 2? We have our sorted takes 2 arguments, right? It's like our function takes 2 arguments in an example, right? If our closure takes 2 arguments, we have to give it specifically 2 names. Doesn't matter what the names are. It could be tuple 1, tuple 2. But you have to, it's required that you have those 2 arguments there, right? So if I have 1 only argument, I'll get a compiler error saying expected 2 arguments, 2 argument names. That is, sorted itself takes 2 arguments. The function itself takes 2 arguments because you need to compare A versus B. So here, I could name it A versus B, but that doesn't give us much meaning to what the things are. So here we say names or name 1, name 2, right? That's probably better, name 1, name 2, as opposed to names. Names is a bit confusing. Yes, all the elements. It compares 2 at a time. Exactly. So it's going to compare Johan and Claudio, and next one is going to compare them as it goes. And it returns that array. Yes? That one is accessing. So we have 2, that's our tuple, right? That's our tuple. It has 2 strings. So the first, if we're trying to access first name, it's .0. If we're trying to access the last name, it's .1, right? Yes? Sorted goes through each element from 0. Same as reduce, same as filter, same as map. It goes like it's a for loop. Basically, it's a for loop.
So this compares name 1 to name 2, name 2 to 3, name 1 to 3 again.
Exactly, until it gets to the end. Okay, cool. So it's very similar to what we did yesterday with reduce to find the largest one. Very similar. Like it goes, it compares it, and then it arranges it accordingly. We'll see what sorting algorithms look like in Unit 3 when we talk about sorted algorithms, but we'll see how this sorting algorithm is the most efficient sorting algorithm to sort things in place, and then we'll see how it happens. Okay, yes?
What is the in keyword?
The in keyword is required like the for in keyword. If we're using long closure syntax here, which we are using, the in keyword is required as part of the closure. If you're just using $0 and $1, just like comparing $0 modem equal to $1, the in keyword is not required, the return keyword is not required. But in that specific task here, it's required as part of the syntax. It tells the compiler, I'm expecting more statements after this. Okay, cool. So we have, oh, we need to return something else. Yes? The elements in the array.
So once it determines
Which one should be the first in that particular instance? It keeps going until everything is correctly sorted. So it's like sorting, like you have a line of people. You want to sort shortest to tallest. You keep swapping them, right, until you have the correct arrangement you want. Until that's done, the sorting algorithm is not done. It's like one of those things, I don't want to go into sorting algorithms yet because that's beyond the scope of currently what we're doing. But just for now, the sorted function here correctly sort it based on the algorithm that it's using from lowest to highest in our case. And it's a closure, it takes 2 arguments. Cool? Part of that is repetition. Again, repetition. You cannot just see those things for the first time and get it right away. Sometimes you watch a movie, you have to watch it twice to really get it. And that's a movie, right? You just sit back and you relax. With programming, you have to keep doing it. The labs, keep doing the labs. Even if you think you got the lab, do it again, right? It's open on, it's on your repo. Do it again. As I said yesterday, write it down, right? Write it down, go through it, and then put it in the computer. Go by it line by line. I don't understand why 2 arguments, right? When you type it into the computer yourself, you see it says, hey, expected 2 arguments, you only passed in 1. Or expected 2 arguments, you have 0. So at that point, you'll understand, oh, sorted takes 2 arguments, I'm only passing 1. There's a problem there. So here we have 2 argument names. The compiler is happy. Everybody with me? If I have 3 argument names, that'll be a compiler error. I'm only expecting 2. Because I could only compare 2 things at once. I can't compare 3 things at once. I can't compare 1 thing by itself. That's weird, right? I need to compare 2 things. A and B, I could compare that. Great. I could keep going. Everybody with me?
Wait, if there's like 3 arguments on the function line,
In that particular one here?
up,
Oh, no, the function definition has nothing. The function definition here has nothing to do with what sorted takes.
no, I mean like, okay, so you said you have a string inside a string, and what if there's another string in there, and then you could do sorted, then compare the 3?
No, you still can compare 3, right? If you have 3 strings, you need to figure out what you want to sort by. Maybe a middle name. If you have middle name, would be the third one or the second one. Then you say, oh, I want to sort by middle name. That's kind of weird, right? But either you want to do first name or last name in that case, but sorted still takes 2 arguments. No matter how many elements in your tuple. Cool? All right, very good. So now we have this sorted. So sorted by itself returns an array. Everybody with me? Everybody with me? Sorted here, when I say names.sorted, it returns us the sorted array. Everybody with me? So in reality, I could say return right here, like that. But that might, boggle some of our minds a little bit. So let's make an array called result here. And then return result. Return result. And our function returns something. Where is my function? Yeah, it does. It returns already, sorry. And if you option click, you said twice? That first return is for our sorted algorithm. Yeah. Actually, we could remove that. You don't need that return here. It implicitly returns. Okay, so move that return there. Okay, but here we need to return the result from our function. And if you option click on results, what type is it? Option click on results, what type is it? On result here. It's an array of tuples, right? So the same array of tuples we got in, we return it, but only this time it's sorted. Everybody with me? Okay, cool. So now, any questions before we continue? Feel free. What's the question?
No, you're letting result equal.
Yeah, so that's our constant, and the result of the sorted goes into our result constant. And we return it at the end on line 21. Everybody with me? Okay, so now let's go ahead and test it. So go ahead and uncomment up to line 25 here. So now we have our first and last tuples. That's the one coming in. And we have our expected output, right? That's what's coming back. And go ahead, uncomment line 43, uncomment the assert, and let's test our code. So press the play button. Cool, so our test passed, right? We had no errors. Our test was successful. So coming in was Johan back as first, right? Last we had Hoskin. And last we have Nikolai here for our expected output, right? So let's see, again, the test passed, we had no errors. Everybody comfortable with assert so far, right? We know assert, if it runs, there's no errors, our test passed, correct? If we want to see the actual output of it, we're like, hey, we want to see what the output is, just to see what the output is. I could print, go ahead and print here, print sorted by last name. Let's pass it. It doesn't know about this guy yet, but go ahead, copy your line that says print sorted by last name and paste it right below. So paste it right below the last let here. Okay? So what are we doing? We're testing it just to see what the print out looks like. So here we have sorted, our function name called sorted by last name. We pass it in first and last tuples, not expected output 4, because that's already sorted. Everybody with me? Everybody with me? So I'm passing in first and last tuple. Go ahead and run it. And let's see what the printout looks like. It should look like expected 4. So our last element is Nikolai, right? Everybody sees that. Right? Christian? Stephanie? Era? Era, how are we doing? Good? Questions? Any questions? Yes.
So we have to put that in version
You mean?
If you want to print something from a function.
Yeah, if you want to print that, if you want to print something that returns a value, you want to put print call the function and then pass in some argument. That the argument we're passing in is the unsorted tuple, is the first and last tuples. Cool? Just to see visually what the printout looks like. But we know our test pass already. Good? But more like a visual representation. Like, hey, what does the thing look like? Is that good? All right. Any questions? Zero, how are we doing? Let's go back to the syntax and then we will close that out. Yes? Yes, sir.
For line
916,
16,
result.
was the point of putting result, we're putting a that's within result,
It was just to return. We need to return a value. Or you could just say return without making any constant here. Cool? Wherever your comfort zone is, that's where. But again, I want to make sure everybody's comfortable with what we're doing. So I put some variable there, some constant that I could return. Yes, sir. Yeah, I could do print there. Yeah, you could do that. Yeah. But there's no, print wasn't required in this. But yeah, you could print anyway. Yeah, that's fine. Any other questions? Anna, good? So again, when you're writing any higher order function, guys, get comfortable with typing in the name of the function you're interested in, like filter, open curly bracket, close curly bracket, and based on how many arguments, put the arguments in, and then continue your logic. You see what I'm saying? Okay? Very similar to if you're doing filter here. Let's just do a quick example of filter. Yeah, higher order functions or any function that takes a closure. Yeah. Or any function. Yeah. No. Any function that takes any function that really takes a closure is a higher order function. But any function you have that has a closure, start off by having, if you want to have extra work done in that closure there, have open bracket, close bracket, and do your logic inside. Don't let the compiler autocomplete for you. Right, let me show you what I'm talking about. So if we have an array here, I'll have an array of some numbers. 4, 5, 1, minus 7, minus 99, right? And the question is return an array where elements are less than 5, for example, right? Go ahead and, actually you guys do it. Get some practice here. So go ahead and use something. Use one of the functions we've seen, the higher order functions we've seen, to return me, the output should be so this should be the output, right? So using one of the higher order functions, go ahead and write code that returns an array where the elements are less than 4, or less than 5, sorry. Where the elements are less than 5. choose one of the higher functions. Whichever one you feel is helpful for that. I see everybody writing a function. That's a one-line statement. Using map, filter, or reduce. Right? So using map, filter, or reduce, you can solve that problem. Guys, go back to the notes on Friday. We have that in there. Our Friday's notes for closures. We have that in there. Your Friday's playground on closures, you have an example of it. Maybe it's more than 7 times. Oh. Yeah, yeah, yeah. Very good. Oh, based on that, okay. Okay. Yeah, good. That's good. Okay, that's good. Oh, okay. Okay, Mr. Eddie, come and complete this for us, please. And walk us through everything you're doing.
Okay, let me make a function that's going to be
We're not hearing in the back.
let me make a function that is called less than 5. Okay, 5.
Oh, you made a function.
Oh, I don't. I can't do without
Yeah,
it.
have a function.
Sure. Let me just say array the filter, and let me take in the first the value is less than 5.
So what's $0?
It's like, so filter is going to loop through each element. So $0 is going to be the current element you are at. And if it's less than 5, I don't want to, I want to return it. But if it's more than 5, I just want to ignore it and I go to the next one.
And how many arguments does filter take?
What?
How many arguments?
How many arguments are?
Filter. Does it take 2 arguments? 1 argument?
Just 1 argument.
1 argument, right? Okay, good. Cool.
That's all right.
Oh, print it out.
Oh.
We might have to sort it as well.
Nope.
Cool. So So great. Now sorted. Can you also sort it?
Sure. Let me just sorted. How this will
Great.
work?
Right there. Great. Perfect. Thank you, Mr. Eddie. Okay, cool. So what Eddie did here, he used filter. Everybody stop typing. He used filter. Filter basically takes a condition, right? The condition that Eddie put here basically comes from the question, right? I only want to get elements that's less than 5. So Eddie wrote it here using trailing closure syntax. He said, filter takes in one argument, $0. So filter goes through every element of the array, very similar to a for loop. It goes from element 0 up to that last element. So here we have element 0, which is the current argument. Is the current argument less than 5? If it is, put it into that new array. Everybody with me? Okay, and at the end, we saw that our filtered results were not sorted, right? So on a filter, you could say dot sorted as well, right? Dot sorted by default just sorts alphabetically. We saw that again on Friday, right? So dot sorted here sorts ascending by default, from smallest to largest. So that's it there for that particular problem, right? I'll give us one more because, again, please look at the Friday notes. We went through filter, map, reduce. That's part of the calculator project, right? And we have to build those from scratch. So we have that in the notes, right? How to use filter, how to use map, how to use reduce. Knowing how to use those are very powerful.
So I think you can also do it same thing with the opposite way where we
Another variable.
another.
Oh, that's fine. So we could, like a first variable for the filtered part. Okay. Okay, so we could say filtered array. Is that good? And then our filtered array will be array that's filtered, right? And again, please, when you start typing in filter, don't press enter like this. Just get rid of it. Get rid of it altogether. Please get in the habit of doing that. And then put your closure here. And now go ahead and put your argument, which is 0 in that case. And we want it to be less than 5, right? So far, so good? So that here gets us the first part of it. Let's actually print that out. So print filtered array. So our filtered array comes out like this, right? Everybody with me? So that's our filtered array. We've removed 5. So far, so good. Let's put some more numbers in there just to see what's happening. So 56, 23. And run it again. Same result, right? So everything less than 5 goes into my new array. Everybody with me? Now it's not sorted, right? Based on what we have here, right? So if we want to sort it, I could say sorted array. Take my filtered array, right, everybody? And say sorted on it. In that case, we're not saying sorted with a closure. There's 2 sorteds, right? There's sorted that takes in a closure, and there's sorted that doesn't take in any arguments. Everybody with me? Put notes down, whatever we need to do. 2 sorted. There's one that takes a closure, one that's by default gives us ascending. So as you type in sorted here, right, you see, you have 2 options, everybody. Option 1, regular function. Doesn't take in any arguments. I want to sort something alphabetically. That's where I go. I'm done. You want to sort something by last name or something more complex? Then you want to go sorted that takes in the closure. Look at our closure, right? Our closure takes in 2 ints, returns a Boolean. Do we see that on the second option? Right? Let me highlight. Do we see the blue highlight there? I take in a closure, int. I take in 2 arguments of type int. What do I return? What do I return? I return a bool. Do we see that? Arrow, bool. It returns a bool, true or false. So if you go in alphabetical, nothing else, use sorted without the closure, sorted with parents. Yes.
There's no way to sort the to sort filter array for the graph and you couldn't string template
String interpolate.
that sorted. Well, not string template, you can do filter array that sorted.
The cleanest you could go here is say filter sorted, or you could say sorted filter.
You can't do it inside
The print statement. Well, I thought we were trying to go simpler, right? But with the variables, right? Simpler is not putting it inside of the print statement, right? With interpolation. Does that make sense? Like break it apart and let's see what's happening, right? And when we get more comfortable, we could go to option line 55, right? But before we really get to that place, let's see what's happening step by step. Everybody with me? It's the first thing we do, we filter the thing. Next thing we do, we sort it. Yes. Yes, sorted. So let me go back again. So sorted, there's two sorted functions. One doesn't take a closure. The first one does not take a closure. No arguments whatsoever. Everybody with me? We see it, right? We see open parents here. No parameters, yes? And the second option, it takes in a closure. It says sorted by some closure where it has two arguments. It's not always type int, by the way. If we're working with a string array, what type will it be? We'll see two strings there. We won't see two ints. Everybody with me? And it returns a bool. Always returns a bool.
Can you keep this way? Something like that. What exactly is the argument? What are you saying? What's the example of what it is?
Okay, so let me read it from the second one that's highlighted in blue. The function signature says, I return an array of integers. That's the first part from reading from left to right. I return an array of integers. My name is sorted. I take in a closure here, which is two integers, right? I'm going to skip the throws part, right? I return a Boolean value, true or false. That's what the function does. That would be back in our sorted example that we did earlier up top, where if you want to do, let me show you, the one using the closure, right? So sorted using closure. Let's put in some names. Do we have names here? No. Let's put in some names here. We'll put in Tiffany. Well, we'll put in Alex here. We'll put in Tiffany. And we'll put in Antonio, right? Put in Genesis. Cool? So we want to sort this by what? We want to probably sort it by, we'll sort it descending. Because alphabetical, if you're doing alphabetical, what should you use? What should you use? Sorted, parents, no closure. You with me? If I want to do descending, I'll go ahead and use the closure and pass it a closure I want. Let's see what that looks like. So here I will say, let sorted names using closure equal to names dot sorted, right? Every higher order function I do, that's how I go ahead to start it. I put the name, I put the closure, and then I continue inside of the closure body to continue it. Everybody with me? Get in the habit of doing that and you won't run into issues. Next step, already it's giving me a compiler error. What does the compiler say? Read. Somebody read. Okay, volunteer read. Right? That's a lot of information the compiler. Thank you, Zara. That's a lot of information the compiler is giving us. It's telling us expects two arguments. I cannot ignore that. I'm the compiler. You can't keep running code without those two arguments. Everybody with me? So now we need to pass it two arguments. We pass it 0, which is the first argument. What's the second argument? What's the second argument? $1, right? So in that case, I want to say descending $1. Right? So here, I'm already done with the closure. I said, take the first argument and the second argument and sort it. This is my sorting here. That's the way I'm telling it to sort. I'm telling it to sort descending, as we said earlier. The more than sign, we said the more than sign is descending. Right? So from Z to A. Right? And the less than sign, this way, is ascending from A to Z. Right? Everybody with me? So now I want to go ahead and print my sorted names. Not this one. Sorted names using closure. Wow, it was that fast today. I barely saw anything. Let me stop it and run it again. Right? So we have Tiffany, which is first, which makes sense. We said descending. Did we say it? We said descending, correct? So it starts from, in that case, the largest element, which is Tiffany, T, right? To the smallest, which is A. That's what we said here. Descended. That's the syntax we used. That's the syntax we used here. More than. Descending, descend. From 7 to A. Descend, go down. Right? Everybody with me? Same applies to numbers. If you say descend, then it will go from 10 to 1. If you say ascend, then it will go from 1 to 10. Go up. As you keep going, go up, ascend. Everybody with me? So this sorted here is using the closure, and the sorted that we saw up here that Mr. Eddie wrote out is not using the closure. That's using just a function. Doesn't take a closure. So using sorted which does not take any parameters. Right? And this one sorted using closure, which takes 2 arguments. Yes.
So all of how this sort of
No. It will keep going through the Unicode. It will go through all the Unicodes and figure out which one comes first. Yeah. All right. So are we comfortable with sorted now? The 2 functions on sorted. Are we? All right. We'll do one more closure exercise, and please go back to Friday, right? Because we're doing the calculator. Today is Tuesday already. We should know the basic functionality of those 3 higher order functions we did. So here, let's do map, right? So let's see. Given an array, actually we'll use the same array up top. Array of names. Return all the names, uppercase. Right, so the input, output. Input is this guy here. Output will be something like this, right? We could continue working on it. We know what we're doing so far. So this is the output. Yes, sir? Don't worry about those 2. You see, if you know the 3 that I just mentioned, those are solid for now. Okay? Cool? Cool. Because I want us to be That should be second language for us before we go deeper into more higher order functions. Does that make sense? Okay, cool. Thank you. Good, good, good. So Alex, Tiffany, Antonio. Like the objective is just to use the syntax, be comfortable with it, know how to write it, know the arguments and stuff like that. Good, good, good. So Genesis here. And for calculator, you don't need those two necessarily. Actually, you don't need those two. Yeah, for the assignment. Yeah, you're good. Okay, so that's the input, that's the output. We good? We know what we're doing. So use one of those three order, high order functions. We have map, we have filter, we have reduce to solve that problem. Okay. Anna, would you please come up and complete this exercise?
Printing?
Very good. Yeah. I'll walk us through what you did. Right? Maybe not on finance, right?
What?
Very good, very good. Walk us through what you did.
So I named it sorted names using map, and I don't know how to walk you through this.
What does map do in that case?
It goes through all of the characters and makes them. I don't know how to explain this.
So map, what does map do? Greg?
Yeah.
Right. So Anna was, thank you very much. So as Greg was saying, map transforms a value, right? The value going in, you perform some transformation on it, whatever transformation you want, right? In our case here, Anna said, hey, for every element coming in here, uppercase it. So it goes through, figure out like a for loop, it goes through that for loop, for every element in that particular collection, uppercase it, right? So our collection here has a collection of strings. So for each string I see, uppercase, return the uppercase representation of it. Do we see that? Transforms all the elements. Yes. Everybody with that, right? Last Friday we saw we squared every element. You could do anything on that element you want, right? You could lowercase it, you could uppercase it, you could turn them to emojis. Whatever you want, transform it, right? That's what map does, right? And it returns to you a collection of that same element. Great. Okay, cool. Any questions? No, ask a question. Somebody else probably has the same question.
No, well, I tried to do like dollar sign or like a small stuff because but it didn't work.
What did you do? Dollar sign what?
Dollar sign.
That uppercase? You didn't get a compiler error? Yeah, so there's no, oh, remember one argument. Map takes one argument. It will be 0. It starts at 0. If there's one argument, it's $0. If it's 2 arguments, $0, $1. 3, $0, $1, $3. Cool? Good, good, good. Excellent. So any more questions, please? Give yourself practice. Go through some array, transform it, reduce it, filter it. Get comfortable with those. That's part of the homework this week, where you have to actually create map. Right? We have to create map ourselves. You could just create like create your name and just return everything that's like, that doesn't have Y in it. Like filter it where there's no Y. That's simple. Like a website for that, we have the labs already. And then a simple exercise like that where you just like have some. Yeah, you could do those too. Or come back to us for like small exercises. Because that's like fundamental exercises. Not too much happening, just how to fundamentally use it. So if you need more, you could see us after. Cool? All right. Any other questions?
Guys, just as like an announcement, please ask questions. Please, because the other class, they did not ask questions and they're really struggling, like really bad with fundamentals. Like they need to go all the way back, add extra days just to go back what they are doing right now. Because they didn't ask questions. Because they just saw what Alex said and that's it. They never really tried to ask questions based on like the concept of it. And now they're struggling. So please, I don't want you guys to struggle like that. Use them as a model, like how to improve. Even if you don't know what to say, don't answer questions. Like talk to him about the concept. Be like, hey, my understanding about what you just told me is this. Is this correct? And then this will help you move on, and you will be able to learn how to ask questions. So please, I want the best of you guys. Please ask questions. Cool.
Thank you, Antonio. Yes?
Is there a way to like use sorted names using that uppercase, like similar to lowercase,
Yeah, you could lowercase.
like without doing
But you have to go through every element. You mean on the entire array at once? No, you have to go through the entire element. You have to go through every element by itself. Because there's no array dot uppercase. You see what I'm saying? Array itself is a collection. You have to go inside of that to see the elements. Because the elements might not be uppercaseable, if that makes sense. You see what I'm saying? So you have to go through each element. It might be ints. Can you uppercase ints? No, right? Good, good, good. But good question, very good question. So you have to go inside of it first. Yeah. No, no, no. I said use map, filter, or reduce. Or. Yeah. Or. I was just telling you guys, figure out which one. That's why we have to understand what they're doing. The map, we know it transforms. Filter, we know it gets a condition and it filters out based on that condition. Reduce, we know it combines, right? But yesterday we did not combine, right? But we went through every element. You could do anything with them based on the logic at the end of the day. And I'm not going to show compact map right now, or I'm not going to show for each, but we'll see them later. I want us to understand the basic ones first, especially that's vital for our homework. Everybody with me? Because our homework says, hey, don't use the built-in map. Create your own map. Map would be a method that you create, a function that you create yourself. It would be, and then you would call it custom map, or whatever map, whatever function name you want to call it. But your calculator doesn't use map from Swift. It uses map that you create from scratch. Yeah, so I'll do it. I'll do one, and then you'll do the other two. So here we'll create custom map. For homework, we need to do map, filter, reduce. Everybody with me? So for the calculator app. So we need to create our own function, right? I'm sorry? Custom map, I said, not compact. No, that's fine. I guess recreating instead. So recreating the built-in map function. All right? We saw what map does, right? So our function needs to do the same thing. Taking an array and do some transformation on it. So what does map take? Map takes in, our map will take in two parameters. First parameter is an array of ints in our case here. Second parameter is a closure. Right? So visualize our function. We're taking a closure, very similar to this, and it would take in an array. Okay? So the array, if we have names, it will take in names, and it takes in a closure. So let's go ahead and define what the function looks like. All the steps I'm doing here is going to be very similar for what you guys do for reduce and filter. Everybody with me? The logic inside is the logic inside. That's your homework. Now function, I will say, call it custom map. My map takes in, what did I say? What's the first argument in that case? An array of ints. What is my second argument? A closure. What's the closure going to be taken, actually? An int, right? Who said that? Right, it doesn't say, but we have to write it, right? Not it doesn't say, but an int, right? It takes an int, and what does it return? What does it return? Remember, it transforms the element, an int, right? So according to a meaning here, it returns an int, right? It takes in an int, for example, it takes in number 4. It needs to return whatever that calculation, that transformation is. I take in 4, if I want to double it, I return 8. Everybody with me? I need to return that same element. So the closure takes in an int and it returns an int. The parentheses here. So sometimes you need them, sometimes you don't. It depends on what you're doing. So here you need it, right, because it's a single argument. So here, if we do not put that parenthesis, we say single argument function type requires parenthesis. So in that case, for that closure, you need to put parenthesis here. It lets the compiler know that's a closure and not a regular argument. For the return type, I don't think it's required, right? But for the argument type, the first type coming in, it needs it. Now, what is a function? What does our function return? Should it return something? Should we return a value? An array, right? Right? So everybody sees that? Compact map returns an array, right? Everybody sees that. Here we use compact map. It returns us an array. Everybody sees that? So we're simulating the same thing that the built-in function is doing. We take an array, we return an array. So there we return an array of what type? Of ints. So far so good. So we have our function definition. We have an array coming in. We have a closure. And then we have our return type on our function. Great. So I'll start out with an array. I'll call it transformed array. I'll initialize it to an empty array of integers. I'll return that transformed array when we're done transforming it. So I declared an array here on line 83. I return the transformed array. I'll use a for loop to go through each element. So for num in array, right? For num in array, perform some transformation and append it to my array. So perform transformation based on closure and append result in transformed array. What does that look like? I have my transformed array. How do we add to an array? Dot append. Okay? In that append, I am going to call my closure and pass it num. Right? So whatever the closure does, it's up to that closure. I don't care. I only want back an int. So I call my closure, I pass it the int. Remember, our closure needed a parameter, right? Everybody with me? If I do not pass in num, I'll get a compiler error. Missing argument for parameter. Do we see that? So my closure expects an argument of type int. I need to pass it the current number. This is the current number I'm looking at in my for loop. Right? We go through the for loop, right? Every element I see, I have to transform it. Everybody with me? So I pass my closure num. I think we're done. Let's test it. So here, let us do using custom map function above. Take in an array of numbers and return the squared value. or values of each of those elements. Right? So we have some input that looks like this. 6, 7. What's our output here? 1, 4, 9, 16, 25. Stop me if it makes no sense. 36, 49, right? Everybody with me? Line 93? 83. 83.
You have int in the brackets, which makes an array of the parentheses after that.
That's the initializer. You cannot forget it. That's a compiler error. Right? It says, I'm creating an array, but you also need to initialize it. And this is called the initializing syntax, the two parents. Required for the syntax. Right? But here for the return, you don't put it, right? You only put the array type without the initializer, because you're not initializing it. You're just returning an array. Cool? So that's the difference. When you first create it, you have the initializer syntax, which is the parents. But after that, you don't use it anymore, because you've created it already. Cool? All right, so here we have our input, we have our output. Who got it to work yet? Who tested it? Amini, you tested it? You had your hand up there like this. Mr. Hart tested it?
Yeah.
Okay. How everything worked out correctly?
Yeah.
Yeah. All right, come and type it for us. Yeah. All right. Do you have to? Yes. You raise your hands. Wait. Use your computer. Use ours.
Oh, wait.
And walk us through the code, sir.
Okay. So we have the function custom map. It takes an array of integers, and we have a closure statement that takes in an integer and returns an integer, and in that whole function returns an array of integers again. So we have a variable transformed array, which is equal to an integer. We initialize a new array called transformed array. I'm gonna change this right now. This is bothering me. I'm sorry. Thanks. All right. So yeah, and we have a loop inside the function called for number in array. That's gonna go through the array that we input inside the function, and inside that for loop, we're going to append a number that we go through with our closure, and then we return our transformed array. That's kind of it. So we're going to use a trailing closure. I'm going to say, do we have a, oh yeah, we have an input. So let number array equals 1, 2, 3, 4, 5, 6, 7. I want to do that. Oh yeah, we're gonna use that as our input for our function custom map. So I'm gonna call that. I'm gonna call the whatever we get from that custom map into let squared number array equal equal to custom map. There you go. So it takes in the array, and for array we're gonna do number array, and for closure I'm just gonna ignore this because we can use a trailing closure, and I'd rather do that right now. And I'm gonna cheat and do this because technically we already have a closure and we already have the numbers assigned through it, so we can use shorthand syntax. And since we're trying to look for the squared input of an array, we're going to multiply the element by itself. If we print it out, it should give us the right number eventually.
Thank you, sir.
Thank you.
Any questions for Hal? Yeah, we'll do it the long way. Yeah, that's fine. That was the one question, right? So if you're comfortable doing shorthand, great. If you're not, do it the long way first. But as Ahad says, please start out with an empty trading closure like that, regardless of which direction you go. Everybody with me? Longhand meaning creating the in, having the arguments, and have in whatever you want to do. We'll do it now, right? So give us an argument name. Anybody? Number, right? If you say square, you're implying it's squared already. You see what I'm saying? Oh. Oh, no. I got you. Sorry. And then you pass it in. That's going to even more confusing. Okay. I got you. No worries. Okay, so what are we saying? The first way Ahad showed us with $0. Everybody with me? That's called shorthand argument syntax. Everybody with me? If you do not feel comfortable with writing shorthand syntax for now, $0, $1, write in some variable name. For our case, we have numbers or we have integers, right? I could start off by saying number, right? So number in. Everybody with me here, right? Everybody with me? Tiff? So number n, this is so far so good. What are we returning now? We need to return something. How do we find the square of that number? So what am I writing? So number times number, right? So far so good? That's very similar to what Mr. Ahad did, minus having the variable name called number, minus having the in keyword. So his was different, where he just, instead of saying number in, he just has $0 times $0. Everybody with me? That's not shorthand. That would be like the longer form of writing a closure. There's no like technical term for it, but it's like the longer way of doing it. Right? Where you have to declare a variable name, required to have the in keyword, and then whatever computation you're doing here on that transformation. Yeah. Right? So, but you only have access to how many variables? One. That's the most important part of it. So you're going to say $0 times $1. That would be a compiler error. Cool? Yes? Yes? That's preferable at the end of the day, right? Because the less code you write, the better, the easier to debug. But again, you will come to writing longer form if you have more complex things to do, like we did yesterday with reduce. So instead of just saying like 0 plus, you go into it using a trading closure like that and have the arguments and perform some more complex operation. Yeah. So being comfortable with both is good. The word number is arbitrary. We chose that variable name. I could say num. I could say int1 or int. Well, not int. Don't call it int. But number, num, whatever name you want. Whatever name makes sense to the collection. Cool? So if we run it again, still works as before. Right? 1, 4, 9, 16, 25, 36, 49. So this is 1/3 of what we have to do for homework. Everybody with me? I'm not going to show you guys the rest. Let's scratch our heads and figure that one out. Yes, sir? Who said it's complicated? You want me to do the complicated one? Then where's the challenge? Oh, from this one? Oh, it got upgraded from this one? Eddie, at the end of the day, it's working, right? Then you could refactor it. You could always refactor.
That's why I said I can upgrade.
Yeah. You could always refactor. Don't bang your head if it's like more stuff. Cool? You should be happy that you were able to do it. And then refactoring is also part of coding. No matter how good you think your code is, there's always a way to refactor it. Cool? Okay, any other questions? Mr. Brandon, you had a question? You figured it out? All right, cool. Good. So know what your closure take in. Yes, Mr. Josh.
We're sort of return transform
What line number am I looking at?
91.
91. This guy.
Yeah, and it says cannot convert return expression type into return type.
So your return type is different. You have an int here. You should have an int array after your arrow. Make sure you have square bracket, int, close square bracket. You probably have this. You probably have int this way.
Yeah.
So the compiler is confused. You told me you return an int, but here you return in an array. Cool? Good. Yes? In your calculator. I know you want to go deeper in there. That's filter. Filter is different, yeah. That's different. That's not a custom. That's not a custom. That just returns you something. It's not a custom. Yeah, that returns a closure. Yeah, but there's no closure in the parameter. It returns your closure. Different. Yes, you are. Yes, we use it on Friday. It gets you. Yeah, we do. We do use it in the project. Project-based questions we'll answer later. Right, but the math factory we have, we do use it in the project based on what the user enters. All right, we'll come to that later, if that helps. But for now, I just wanted to show you guys how to create your custom map. That's also for the project, because remember, it does map, filter, and reduce. I know you're trying to solve it like all in one shot, right? But there's a lot of parts to the project. That's one of the parts where the user says they want to map an array. They put in map with the array they want to map, and it gives them the return. That part you're looking for is the basic math arithmetic. Addition, subtraction, multiplication, and division. Cool? That has nothing to do with the higher order functions. All right, cool. So I will stop here.